Hello, welcome to our 2.5 statistics video lesson. If you can tell already, it's a little bit of a different format. My little picture box looks different. I look a little bit different. Hopefully this will fix some of our delay and some of our lag. My webcam is up here, but everything we'll be doing is down here. So if you see me look down a lot, it's just because I've changed some things around and I apologize. But I'll look up here as often as I remember to. That way it looks like I'm actually speaking into the camera and not just looking down all the time. So go ahead and put 2.5 statistics and today's date. Alright, and our I can statement, what we hope to be able to do by the end of the lesson, is I can analyze and construct data in different forms. Now we'll go ahead and start looking at some of our vocab. Our very first vocab word is a line plot. It's one of the first ways we're going to be constructing our statistics is in a line plot. Line plot is a number line that shows data with X's for a number's frequency. Okay. And the next one is frequency, because there it's used in line plot, and frequency is how often data occurs. So a line plot, you just make a number line, you put an X above that number every time it occurs, and then the frequency just means how often. So for every time you see that number, we're going to put an X above it. Alright, so we have our stem and leaf plot, and it says greatest common place value is placed in stems, and next to place values are leaves. So I know that sounds a little weird right now, but when we get into an example, you'll see it. So the big thing about this one to remember is that greatest common placeholder. Okay, so common means it's throughout. It's what the majority of them have. And the place value means tens, hundreds, thousands. Okay, and then in our stem and leaf plot, we're going to see a back-to-back. Sorry about that. Okay, so a back-to-back stem and leaf plot is when a stem and leaf plot compares two sets of data with the stem in the middle. So when the stem is on the left, work from left to right. Or sorry, from right to left. So we're going to have to work backwards, work right to left whenever we have a back-to-back one. So back-to-back, the big part in red is that we're going to have to work backwards from right to left when we have a back-to-back stem and leaf. Alright, and then our measures of central tendency. Our first one is mean. And oftentimes people refer to the average as the mean. So it adds all the numbers up and then it divides by the total number of numbers, so however many you have there. The median is often easy to remember that it's the middle, like the median in the road is the middle of the road. So median is the middle number when the data is listed from least to greatest. Okay, and our last one is our mode, and mode occurs most often. Alright, and just a quick reminder, in median, if you have two numbers, you find their average. So median, if you end up with 2 in the middle, you just find the average of those two numbers, and in mode, the one that occurs the most. Okay. Now I want to go ahead and tell you that the examples have a lot of numbers in them and a lot of writing. I'll only write what I write in my pen. That way it saves us from having to write so much. So, example 1. We're asked to make a stem and leaf of our data. So, go ahead and write down your number 1. Start with your stem and leaf plot. Start with your line plot right here. So, it says use a line plot to solve. The speed is miles per hour of 20 of the fastest land animals are listed below. So go ahead and list out these numbers in your notes. The numbers are 45, 70, 43, 45, 32, 42, 40, 40, 35, and 50. So we're going to look at our line plot first and those group of numbers. So if you go ahead and look down here, Line plots are when you make a number line. So go ahead and make a number line. I just did every 5, so if you just want to do every 5. So I started with 30, 35, 40, 45, 50, 55, 60, 65, 70. And at this point, I'm going to remind you, you can pause me at any time if you need a little bit longer to draw your line out, your number line. So if I go too fast, just pause me and then push play when you're ready. So our very first number up here is 45. Next number 70. Put an X above 70. 43. So go to 40, then up 1, 2, 3. 45 again. 32. Down here, so go to 30 and then up 2. Alright, 40. Right beside 43. 40. 40 again. Then 35. And last one's 40. Or, sorry, 50. Last one up here is 50. So if you look at the example and you look across your number line, the line plot shows the frequency. So if you look right here, 40 miles per hour and 45 miles per hour both have 2. So they would be the ones that occur most often. Okay. Our second example has our stem and leaf. So if you'll just real quick, we're going to make a stem and leaf plot and write out these numbers in your notes. Okay. 108, 104, 86, 82, 80, 72, 70, 62, 64, 68, 84, 64, 98, 96. Okay, so for a stem and leaf chart, you'll need a T table like what's already here. We label the left side of it our stem and the right side of it our leaf. I'm going to refer you back real quick to the definition of stem and leaf plot. It says the stem is made up with the greatest common place value. So you have a couple of place values, but only have 2 in the 100s. So that's not my most common. My most common is actually the 10s. I have all the rest of them have a number in the 10s placeholder. So I'm going to put all my 10s in the column in order from least to greatest, and then write out their leaves. So for this today, we're going to have our 10. So let's look across there. What's our smallest number in front? What's our smallest 10s placeholder? Okay, 6. And then I have a 70. And I have a number in the 80s, so 8. And then 90s. And lastly, 100s. And for 100s, I'm going to have to put 10 because that's my placeholder, or it's in the 10s and 100s. So I'm going to have to put 10 in my 10s place. All right, then we're just going to go through, we're just going to find the smallest number, and we're going to write the 1s in the leaf. Just a reminder, our stems are 10s, our leaves are our 1s. So our smallest number here looks to be 62. So, 10 is 6, 60. Mark him off. My next one is 64. And right here I have another 64. So mark him off. And I have a 68. Then we're going to look through here real carefully, make sure I have all my 6s and all the numbers in the 60s. I do. Now we're going to move up to the 70s. So look for all the numbers in the 70s from lowest to highest. So I'll start off with 70, which is 0. So 7 and 0 make 70. Mark it off. Then I have 72, so put my 2. Mark it. So after we look through our 70s, We look, I don't have any more numbers in my 70s, so I'm going to go back and look for my 80s. So 80, so 80, mark him off. And 82, so that's a 0, and this is a 2. And 84, so 4. And 86. Let's look across there, make sure I have no more 80s. I don't. So now we're going to move on to 90. So we already have our 9 for our tens place, and we're going to look for our smallest 90. So it's 96, so I'm going to put the 1, 6, and then 98, so I'm going to put 8. And then we look at our 100s. My 100 is 104, so I put my 4, and then 108. Now, whenever you make a stem and leaf plot, we also need to make a key. That way, whoever looks at our stem and leaf plot will know that the 10s are on the left and our 1s are on the right. So what we're going to do is just go grab our first one up here. 6 bar 2. So I'm just going to write down here. 6, and then the bar that separates my 10s and my 1s. 2, and we're going to put equals 62. So whoever looks at this stem and leaf plot will then know that 6 and 2 means it's 62. Now, for this stem and leaf plot, we're going to be asked just a couple more questions, like what is the difference between the highest score in each class? So difference means we need to subtract between the highest score, okay, and it should say in the lowest, so I don't know what's wrong with that one, in class. Okay, and so we look across here, and we have our lowest score is 62. Okay, and then our high score is 108. So 108 minus 62. 46 for the difference between the high score and the lowest. Or should say what is the highest overall on the test, and that would be our 108 is our highest. Now for our last one is finding the measures of central tendency, and we already said measures of central tendency are our mean, median, and mode. So it gives us our data, and it says numbers below represent the ages of the U.S. presidents since 1900 at the time they were inaugurated. Which measure of central tendency best represents the data? So go ahead and write out the data. We have 42, 51, 56, 55, 51, 54, 51, 60, 62. And the very first thing we're going to do is find the mean. So write down the mean. Alright, now the very first thing we're going to do is take all these numbers and add them up to find our average. So 42 plus 51 plus 56 plus 55 plus 51 plus 54 plus 51 plus 60 plus 62. Alright, and then we're going to have to divide the whole thing by how many numbers we have up there. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. Yep, double check ourselves. So, next all you need to do is add up all those numbers on top. So 42 plus 51 plus 56 plus 55 plus 51 plus 54 plus 51 plus 60 plus 62 gives us 482 divided by 9 still. Now we divide by 9 and we get 53.55 more on 53.6. So that's our median. Sorry, that's our mean. Our mean age is 53.6. Let's try to scoop this all over just a little bit, so give myself some room. Alright, so now we're off to the median. The median wants the numbers in order from least to greatest. So we're going to find our youngest age is 42. Okay, and then our next youngest age is 51, and I have 3 of those. So 51, 51, 51. So 1, 2, then a 54, 55, 56, 60, and 62. So once your numbers are in order from least to greatest, we're going to find the middle one. So we're going to mark them all off. So 42, 62, 51, 60, 51, 56, 51, 55, which puts 54 in the middle. And the very last one, the mode, wants the one that occurs most often. So if you look up here, the number that occurs the most often is 51. And I'll go back and just highlight the question again. Our question asks, which measure of central tendency best represents the data? So this one's one of those cases where it's just down to looking at the results. We have our median is our mean is 53.6, our median is 54. Those numbers are kind of close, and if you look, our lowest number is 42 and our highest number is 62. So that's somewhere in the middle. And the mode is 51. Now if you compare it to our other two, our mean and our median, 51 is a bit low. So our best representation of the data is the mean or the median. So for this one, the mean or median would be best. And then we're asked that, whenever you look across your data, just look to which one best represents the data. And for this one, like we said, it could be mean or the median, but the mode's a little too low. And that's it for our line plot, our stem and leaf, and our measures of central tendency. Tomorrow we'll have an up check and continue on. Thank you.